done this question? Is anyone still doing part 1 and 2?
Is that increasing function?
What is it?
Increasing functions.
What chapter is that? 15? Were you not here?
I did.
Okay, are we done? Any questions regarding part 1 and 2? Okay, so for part 3 itself, we are required to show that y increases as x increases between the stationary points. So y increases as x increases, what this implies is that it is going to be an increasing function. Alright, so if you recall, that is what we did in chapter 15, okay, knowing what is an increasing function. Okay, how do we show that it is an increasing function? What is the property or the thing that we're going to be looking for increasing functions? Okay, if you cannot recall what is the dy over dx, at least have a image in your mind what an increasing function would like. So increasing function, we know that when x increases, y increases, so something like that. Okay, then after that the derivative will always be requiring you to look at the tangent. So the tangent itself will always be positive. So that means your dy over dx must be more than 0. Okay, so that is the thing that we need to show, right, in order to prove this question. Okay, and then between the stationary points, that means that we're trying to prove, okay, for the interval from -1 to 2. Okay, so this is what the question actually basically wants. They want you to show that dy over dx is going to be more than 0, right, when in the interval -1 to 2. Okay, so dy over dx, we have earlier found out that it is actually -2x squared plus 2x plus 4 over x squared plus 2 squared. Okay, so if I were to actually factorize this, which I can, I will be able to get this. Okay, so I need to verify that for every for this interval itself, every single part of this fraction, it will always be more than 0, or else if it's negative, there must be double negative such that it becomes a positive, because we know minus minus is plus, right? So if this were to be negative, this negative, then it will cancel to become positive, then the other one must still be a positive. Okay, so looking at the interval, I erase this up. Okay, in this interval itself, let's look at x minus 2 first. If I have x minus 2, okay, that means I minus 2 on both sides. Minus 1 minus 2, 2 minus 2. So, okay, x minus 2 will always be negative. Or rather, it will be negative between -3 to 0. Okay? Then after that, if I were to look at x plus 1, it will be less than 3, but it will still be positive. Okay? Then after that, for x squared plus 2, okay, it will surely be positive since there is a square in between. Okay? Leave it out. 0. Okay, so this part is going to be negative. So this part here negative, and then this part here is positive, and then this part here is positive. Okay, but take note that this is -2. Okay, so -2 times negative, then positive, positive. Alright, it will still be an entire fraction that is positive. Okay, the reason why I have to factorize the numerator, okay, before I proceed on, is that at this juncture it will be very hard for me to determine based on this inequality, okay, whether is it going to be entirely positive or negative. Okay, that's why it's necessary for you to do the factorization. Okay, then we only know how to actually do inequalities in a linear form. Okay, so that's why we need to do it in the linear expression part. Alright? Any questions? Are you okay?
So you do have to show all.
Yes.
Like that.
Yes. Show everything. Yeah, I've written on whiteboard.
Technically, it's the explain.
Huh? It explains what? Because if I read this, it's for this interval, x minus 2 is less than 0, more than negative 3. So this is negative. X plus 1 is between this interval, it is always positive. So x squared plus 2 squared is more than 0. So it is logical. Yeah. I will, as a marker who knows maths, they will be able to interpret and understand your mathematical writing. Okay? You do not need to write in English words for the marker to be able to comprehend. Okay? But this doesn't mean that you write everything in symbols. Okay? So there are certain things that you should still write in proper statements. Okay? Any questions? Okay, we just do one more question before we call it a day, then we'll end off this section. Okay, so it's given that the curve has an equation of the form y equals to ax plus b over x squared, and then it has a stationary point at 3, 5. Okay, we want to find out what is a and b. Okay, so since we're looking at stationary points, we should differentiate this. Okay, so dy over dx will give you a minus 2bx to the power negative 3. Okay, so at 3, 5, okay, we know that dy over dx will be equals to 0. Can I erase the previous ending? Can I erase this part? Enough? So this, okay, the derivative at x equals to 3 will give you equals a minus 2b over 27 to be equals to 0. Okay, so therefore a is equals to 2b over 27. Okay, so since we know that the point 3, 5 satisfies this equation because it is a point on the curve itself. Okay, so when y is equals to 5, we will sub in 5 and 3. So therefore we will now have two equations. Then we find that a is equals to 1 and 1 over 9 and b equals to 15. for this section. Homework 4 questions. Okay, question 5, 8, 13 and 14. Right, due on Monday, can? Any questions?